Welcome. This video is your free introduction to how education research works, from the moment someone identifies a problem worth studying, all the way through to findings that can inform policy and practice. No prior research experience needed. By the end, you'll understand the cycle that underlies every study you've ever read about. Before we get into the steps of the research cycle, it's worth pausing on what makes something actually count as research, as opposed to opinion or anecdote, or a well-intentioned guess. Research is disciplined. It starts with a genuine question, not a predetermined answer. It uses methods that are planned in advance and applied consistently. And critically, it's self-correcting. Good research invites scrutiny. It gets replicated, challenged, built upon. That's not a weakness of the scientific process. That's the whole point. When you see an education study that was done well, you should be able to read exactly how it was conducted and decide for yourself whether you trust the findings. That transparency is what separates research from advocacy, even when the findings point in the same direction. With that foundation in place, let's talk about the two main traditions within education research and why this course focuses on one of them. Before we get into the research cycle itself, I want to spend a moment on something that trips up a lot of people: the difference between qualitative and quantitative research. You've probably heard both terms. People sometimes use them interchangeably or assume one is more rigorous than the other. Neither is true. Qualitative research is built for how and why questions. It gives you depth, the texture of someone's experience, the logic behind a decision, the meaning that gets lost when you reduce everything to a number. Interviews, focus groups, ethnographies. The findings come out as themes and patterns, not statistics. That takes time. Skilled researchers have to read, code, and interpret the data, and even with AI beginning to help with that work, it's still genuinely labor-intensive. And because the samples are smaller and more specific, the findings don't always generalize. Quantitative research is built for how many and how much questions. It trades depth for scale. Surveys sent to thousands of schools, administrative records covering millions of students, assessments given to nationally representative samples. The findings are expressed as estimates, distributions, and statistics, comparable across time, generalizable to a population, and reproducible. Both are legitimate research traditions, and the best studies often use both together. So, why does this course focus almost entirely on quantitative? 3 reasons. First, federal education data, NAEP, NCES surveys, IPEDS, state administrative records, is almost entirely quantitative by design. That's what these agencies were built to collect at national scale. Second, and this is something the public rarely knows, federal disclosure rules actually prevent agencies from publishing qualitative responses. Even a carefully anonymized quote can identify someone in a small school district or a small demographic group. The privacy risk is real, and it's why you won't find verbatim interview data in a federal dataset. Third, for the kind of policy questions that federal data is designed to answer, how many students are meeting proficiency standards, how teacher preparation varies by state, what the graduation rate is for a particular population, quantitative methods are simply more efficient. They get you generalizable answers at a scale that matters for national policy. None of that diminishes what qualitative research can do. It just explains why, for the purposes of understanding federal education data, we're going to spend our time here. Here's the big picture. Research doesn't move in a straight line from question to answer. It moves in a cycle. You identify a problem, you turn it into a research question, you design a study to test it, you collect data, you analyze what you found, you report it, and then, almost always, the findings raise new questions that send you back to the beginning. This circularity isn't a flaw in the process. It's how knowledge actually accumulates. No single study proves anything definitively. What builds our understanding is the weight of many studies, each one refining, challenging, or extending the last. That center circle, new questions, is where science lives. Federal education datasets like NAEP and IPEDS have been feeding this cycle for decades, and understanding how they fit in will make you a much more sophisticated consumer of education research. Every study starts with someone noticing something, a gap, a discrepancy, something that doesn't add up. Maybe a teacher reports that students seem less prepared than they used to be. Maybe a policymaker notices that a particular program isn't producing the outcomes it promised. Maybe a researcher reads 3 studies that contradict each other and wants to know why. That observation becomes a problem statement. But a problem isn't yet a research question. The translation matters enormously. A good research question is specific enough to be answerable, grounded enough to be testable, and meaningful enough that the answer would actually change something. Why are students struggling is a problem. Do students in schools with extended learning time show higher reading proficiency gains than matched peers in schools without it? That's a research question. Notice how the second one tells you exactly what data you'd need, what comparison you'd make, and what a finding would actually look like. Once you have a research question, you make your best educated guess about what the answer will be. That's your hypothesis. The null hypothesis is always the conservative one. Nothing is going on, there's no difference, there's no effect. The alternative hypothesis is what you actually expect to find. You then design your study to test whether the data supports rejecting that null. The design is where most of the consequential decisions get made. An experimental design, where you randomly assign participants to conditions, is the gold standard for establishing causation. But in education research, true experiments are rare. You can't randomly assign children to schools or randomly assign teachers to classrooms in most real-world settings. So we rely heavily on quasi-experimental and observational designs, which can tell us a great deal about what's associated with what, but require much more care in how findings are interpreted. You'll also see the term mixed methods, studies that combine both quantitative and qualitative approaches to get at questions that neither could answer alone. We covered that distinction earlier, and it applies here too. The design choice always reflects what kind of answer the question actually requires. The design isn't just a technical choice, it's a statement about what kind of claim you're entitled to make. This is where the rubber meets the road, and where a lot of studies quietly succeed or fail. The data collection method has to match the research question. If you want to know how teachers feel about their working conditions, you need to ask them in an open-ended way. That's qualitative territory, and administrative records won't get you there. If you want to know what courses students actually completed, transcript data is more reliable than student self-report. Federal education data is collected through several main mechanisms: large-scale surveys like the National Teacher and Principal Survey, administrative record systems like IPEDS, assessments like NAEP, and increasingly linked data that connects multiple sources. That last category, linked data, is one of Agora's areas of particular expertise. Connecting, say, CTE course-taking records to labor market outcomes years later is how you answer questions that no single dataset can address alone. Whatever the method, 2 things always matter: who responded and who didn't. Non-response is never random, and it always requires careful attention. Analysis is where the data starts talking, but interpretation is where you decide what it's actually saying, and that distinction matters more than people realize. Descriptive analysis tells you what's there: counts, averages, distributions. Inferential analysis asks whether what you found is likely to be true in the broader population. Regression analysis lets you hold other variables constant so you can isolate the relationship you actually care about. But the hardest part of analysis isn't the statistics. It's resisting the temptation to overclaim. The single most common error in education research, and in how it gets reported, is treating correlation as causation. Just because 2 things move together doesn't mean one is causing the other. Both might be caused by a third factor you haven't measured. This is why good research is explicit about its limitations, not as a disclaimer buried in a footnote, but as a genuine part of the intellectual honesty that makes findings trustworthy. A good research report does several things that a bad one doesn't. It clearly separates what was found from what was concluded. It describes the sample and methods in enough detail that someone else could replicate the study. It states the limitations honestly, not defensively, but as genuine guidance to the reader about how far the findings can travel. And it points toward the next questions. That last piece is underappreciated. The studies I find most credible are the ones that are clearest about what they didn't answer, because it tells me the researchers understand the boundaries of their own work. Audience matters too. The report Agora produces for a policy organization like the Human Rights Campaign Foundation looks very different from a technical report for other researchers, even when the underlying data and findings are identical. Knowing your reader is part of doing the work well. Here's something that doesn't always get said explicitly. Federal education datasets aren't just resources that researchers use. They're participants in the research cycle at every stage. NAEP trend data identifies problems worth studying, persistent achievement gaps that researchers then try to explain. Federal surveys like the NTPS give researchers the raw material for secondary analysis without having to collect data from scratch. The restricted use data files that NCES produces allow qualified researchers to ask questions that can't be answered from public tables alone. And findings from research, including outside academic research, feedback into how NCES designs its next round of data collection. That feedback loop is one of the reasons the loss of institutional capacity at NCES is so consequential. It's not just about losing data, it's about losing the people who understood how to make that cycle work. Research is how we move from "I think this is true" to "here's what the evidence shows." It's never perfect. Every study has limitations, every data set has a boundary, every finding invites a follow-up question. But done well, it's the most reliable tool we have for understanding what's actually happening in our schools and what we can do about it. The researchers at Agora Education Research built their careers doing exactly this work, designing federal studies, collecting and analyzing data, and translating findings for policymakers, practitioners, and the public. We're glad you spent this time with us today, and we hope it's given you a clearer window into how education research works. There's always more to learn, and we'll be here when you're ready.